Let's try to understand more of recursion by another program to print reverse of a string. So you try to solve the problem, and while explaining this problem, I will tell you one more approach of approaching a recursive problem. Now let's try to discuss the solution of this problem. So the problem statement was that if I have a string called prep, then the resultant should be PERP, the reverse of the string. And mind you, we just have to print the reverse of the string. We don't have to revert the string. So we have two approaches to solve a recursive problem. One is using stacks and another is recursion tree or a tree. So what happens in stack is, so let's say I have this prep in memory, and this will have address from 10 to, this will have address 12, this will have 14, and this will have 16. Let's say integer is 2 byte. So this is PREP. So when we call this reverse here and we pass this string A or character array A, then this str receives the address of the first element of this array A. Now when we do str plus 1, initially the address is 10. Now when we do str plus 1, the address becomes 12 and the recursive call goes like that. Now let's see what is happening in the program using the stacks. So let's say first reverse A is called. Let's say we have main at the bottom of the stack. Then reverse A is called. So let's try to see what is the address that is getting called. So we have reverse, the address will be 10. Now here what happens? It checks whether str is null or not. It's not, so it again calls reverse str plus 1. So now reverse 10 plus 1, str plus 1 reverse 12 is called. The address that is getting called is passed is 12. Now we have reverse 14, again reverse 16, this is a null, no, so reverse 16 is called. Now the address is again incremented by 1 and reverse is called. In this case str becomes null, so it comes back to this place. So what happens is, whenever such thing happens, then apart from the function call that is getting stored, one thing also gets stored, that what will be the instruction that will be executed next. So in this case we have only one statement, printf. There may be a condition where we have more than one statement. So after this function call is done, all the statements that are after this function call get executed. So let's say we say that this is 1, this is 2, this is 3, this is 4, this is 5. So this is the statement number. So let's say in this case also, in every case after the function call 5 has to get executed. So we store here that statement number 5 has to be executed. So this is the statement number that we store. So after reverse 18, after we call reverse 18 and reverse 18 is returns, so this is removed from the stack and reverse 16 is, and the statement after reverse 16 is executed, which is printf star str. And what do we have as the address of str here? 16. And what is the value at 16? P. So P gets printed. Now again after this is executed, this is removed from the stack. It again comes back to reverse 14, and what is the instruction that has to be executed? Line number 5. And star str is, what is str in this case? 14. What will be star str? It will be E. Now E gets printed. Again after this is done, this is removed and control comes to here. Then again what is the str here? 12. And what will be the star str? The value at address 12, which is R. So R gets printed and this is removed from the stack. Similarly after 12, control comes to 10. Now what is the value at 10? It is P. So P gets printed. So the reverse gets printed. Another way is we make a tree. So let's say when we have a main call here, reverse 10. So after reverse 16, what reverse 16 does? Okay. What reverse 10 does? It calls reverse 12 and it prints, it has to print 10, whatever string is there in the 10 position. What reverse 12 has to do? It calls reverse 14 and prints the string, whatever string is there at 12. What reverse 14 does? It calls 16 and it prints 12, sorry 14. Reverse 16 further calls reverse 18. Now when reverse and prints 16. Now reverse 18. What happens when reverse 18 gets called? It returns from here only. So there is no further function call that's happening. One thing to note here is, in this recursive call, how is the function going? So at the right hand side, we keep the function that is being executed first, or that is getting called, and in the left hand side we put statements that has to be executed. So it goes like this: first reverse 10 calls reverse 12, reverse 12 calls reverse 14, reverse 14 calls reverse 16, reverse 18, and after the reverse 18 returns, or the function call is finished, recursive call is finished, it starts executing from here. So what happens? 16 is printed. Print 16. What do we have in 16? P, print. So after this, the 16 is removed from the memory and 14 is printed. So after this 14 we have E. Again after 14 is done, this 14 is already executed, we get print 12. So we get R, and again print 10 is executed and the function returns to main. So let's say if we have had a case in which we had more than one statements to be executed after that, so we will have more branches accordingly. Let's say we have another function, and let's try to solve this using recursion tree, using tree approach. So first let's say we have the same array prep with the address 10, 12, 14, 16. So in the very beginning, reverse is called with the address of 10. So we have reverse 10. Now the reverse has three things to do. It will first call reverse 12. It will print whatever is there at the 10, and then it again calls reverse 14. Now since the execution goes this way, this will be the first statement to get executed further. Reverse 12 will further call reverse 14. It will print whatever is there at the 14, and it will call reverse 16. So again, since reverse 14 will be the first call to get executed, so this is what's happening. So what is happening is, reverse is coming here, it is executing this function, and it is keeping in stack that okay, after this function, after this call is finished, I have to execute this. Then again it is coming here, and it is continuously storing what has to be executed next. So now reverse 14 will call reverse 16, will print 14, sorry, it will print 12, will print 14, and will call reverse 16. It is reverse 14. Again reverse 16 will be executed further, it will call reverse 18. Now since reverse 18 has nothing to execute, it will return here, it will return here back, and the instruction that is to the exact left of the reverse 16 gets executed, which is print 14. Okay, sorry, it is one, print 16 is also here. So first print 16 gets printed, which is P, and then it comes by here and print, which is E, and P gets printed. Now whatever is left to this print gets executed, reverse, which is reverse 16. So reverse 16 further calls reverse 18 and prints 16. What do we have in 16 place here? P. So P gets printed because reverse returns, because reverse has nothing to execute, so print is executed. So after print is done, this is already executed, it goes back to print of 12. So what is to be printed at 12th position? We have R, so R gets printed. Now again function goes to here. Reverse 14 will further have its own tree of execution. So let's say we have reverse 14, okay, let's write reverse 14 here. Reverse 14 will further call reverse 16 and print 14 and reverse 18. So so again this will further form a tree. So this is how we keep on forming a tree. But this, as you can see, that when we are trying to form a tree, many times it may happen that tree gets very big and it is difficult to manage. So in that case you use the stack approach. We use tree approach. Approach is sometimes really good for understanding a code. So whenever you see a recursive code and you're not able to understand, then you can draw such kind of trees and it will be very easy to understand. And but when it becomes really big, you will need a really big paper to understand. So we have a stack method as well as tree method to solve a recursive code. It's up to you that how do you want to go for it.